So, like I told you before, now we're done with the chapter 21, and we're skipping 22 and 23. We'll get to 24, but I'm only going to discuss a few things on chapter 24, and I would like to hold a review session today. Okay, so I'll probably hold a review for the recent chapters, like 20, 21, 24, today and on Monday. But like I said before, from last week, if you keep watching the review sessions that I hold for exam 1 and 2, will be helpful because the final exam will be comprehensive. So I cannot cover the whole review on each chapters, but it's open book test. So just try to look it up and see how you can solve the problem. Or may I tell you almost everything that you need to know for the final exam. So historically speaking, people do really well on the final. So you do the same. Okay. So yeah, chapter 24 is about the means and also heterocyclic compounds. For this one, I'm going to talk about only one subchapter, that is the synthesis of amines. So this is, I think, 24.6. So this is the main subchapter I want you to look at only for 24 chapter. Okay, chapter 24. Okay, so this is the one that you might see on the final exam. Okay, nothing else on chapter 24. Okay, just this one. Okay. All right. So I chose this one because this is most relevant to what we've been learning in this semester. Okay. So if you have carboxylic compound over here, as you remember, you can. This is a very poor leaving group here. Okay, this is very poor leaving groups in your carboxylic compound. So this is also what we did before, right? Thionyl chloride to make it better leaving groups. Okay, and then we're going to treat the ammonia. Okay, so what you're going to do is you're going to just remove this one by making a better leaving groups. Okay, which is still poor group, but this will be make better leaving groups, and you're going to switch to the amino groups over here. So we are the amino groups over here, and then you just need to treat it. One more thing that we did before, right? Lithium, aluminum hydroxide with the just ether base. Okay, so this is, if you guys remember this one from the Wednesday lecture, only the trick you can do is remove the O carbonyl groups. So will be amine compounds. So this is what we did before in 21. Okay, but we added this one too. Okay, so we're synthesizing the amine compounds. Okay. So maybe let's try let's try this one. Bless you. Okay, so try this one, benzoic acid. Okay, and try to get the final product with this mechanism. Okay, so try to replace this poor leaving groups, the amine groups, okay, amino groups, and then try to do the mechanism we did last time to make the carbonyl group gone, and what might be the final product. Okay, maybe 1 minute or two. Okay, so yeah, so if you get this one over here, we just copy the rest same, but thing will actually happen over here, right? So you're gonna have initially amide groups, but will be replaced, well not replaced, but this will be gone by this one, so it'll be the amino group will be amine compounds here, okay? So that's it. Let's do just one more and move on. Okay. Try this one. then we'll move on. Okay, just one more. So we'll do the same. Try to make the better living groups and switch it to the amino groups, and then you can try to eliminate the carbonyl parts of the compounds. That's pretty much it. Okay, about 10 seconds. It's ether. Sorry. Is something wrong in this chart? Anyway, okay, so you can just copy the same thing over there. Oh, not here. And then I'm just gonna remove this part here, and I'm gonna switch this one to the amino groups here. Okay, so this is gone. The carbonyl group is gone. It's switched to the amino group. Okay. That's it. So this is very good because this is what we already know. Just some combination. So you can also do some synthesize the main compounds based on switching your nitro group when it's on the benzene ring. So it would be nitrobenzene. We can treat it with some reducing agent. Okay, so we can do. This is what we already know before, right? Okay, we have some hydrogenation, which is a reduction with some catalyst, platinum catalyst. You can sometimes do this one. This is also what we did for the conjugate ring reduction, which is a the benzene ring here. But anyway, so either these two will show you some reduction over here. The only thing you have to do is actually pretty simple trick you can do. Whenever you see the where you have a nitro group, just switch it to the amino group. That's it. So there's an NO2 here, right? When you do the reductions, because reduction meaning they're going to remove the electronegative element bond. So this O2 will be gone and switch it to the H2. So it will be reduced on this nitrogen right there. Okay. So either you can these two. There's actually one more with the ion acidic condition, but I think these two are the main. Okay. So this would be the some good way to do make main compounds. Okay. So maybe can you guys try this one? Okay, this one. So just look for where the nitro group is and switch to the amino group. Okay, just maybe 10 seconds. Okay, so so just copy the rest. It's the same because you only happen on the nitro group. So I'm gonna copy the aldehyde group over here with the aromatic ring, but I'm gonna switch this one to NH2. That's it. Okay. So that's the only difference you can make from this mechanism, this reaction. So this is another way you can make the amine compounds from the nitro group. Okay. Makes sense, right? Can I move on? Okay. All right. So this is a bit tricky one. I don't think it's. So well, if you have some carbonyl groups, certain ketone compounds. You can treat it with ammonia, and you can do the same with the hydrogenation, or you can use the sodium borohydride. Okay. So only thing that you need to remember from this ketone compounds when you treat with those two, it's pretty much the same what we already did. So this goes to there, which is electron poor carbons over there, and then you're just gonna add another hydrogen to make this one push and to leave. So this will be gone by another addition of hydrogen. Either your hydride sieved or the hydrogenation from the catalyst. So eventually, the carbonyl group will be removed on ketone, and it will be replaced by one amino group and another hydrogen. So this is also another way you can make the amine compounds. So it's almost the same mechanism that we already learned previous chapter. So just the nucleophile attack on the electron poor carbons, and just they make the deprotonated hydrogen with the hydrogenation, either hydride sieved on the carbon 2, so you have only amine groups with the hydrogen, so become amine compounds. So this is another way. Try this one. Okay. So okay, so yeah, just gonna do this one, copy the same thing, but the carbonyl will be removed by substitute by those two. That's pretty much. So yeah.
Does it matter which way?
No, no.
Okay.
Doesn't matter. Yes. So normally, yeah, doesn't matter. All right. Okay, so let's move on to the last one that I want to talk about in this chapter. This is kind of a tricky. Oh, I don't think it's tricky. Just longer process. Okay, so if you have this one over here, what happens to this one is they become. So we call this a Hopman rearrangement. Hopman rearrangement. Because this R group eventually moved to here. So we will rearrange it. So there's carbon here, right? Here's carbon there. But eventually this will move to here. So what they form is this one. So so I'll show you the mechanism real quick, but I want you to just remember this one, okay? So it's not like here. It's not like this one, okay? Don't get me wrong, okay? It's not this one. It's actually this one. That's what happened. Okay, so that's why we call this rearrangement. It's not just okay. All right. Okay, so what happens to this one is whenever you have sodium hydroxide, which is base conditions, you have hydroxide anion picking one of the hydrogen. Okay, so this will become gone, and that pair of electron goes to here, nitrogen. Okay, and this nitrogen with that pair of electron pick up the one of the bromine over here. Okay, and then this goes to there. It's a bromine anion, and this bound to now one hydrogen and one bromine. Okay, and then another, because it's a base condition, there's a lot of OH minus. Grab another hydrogen over there, and it becomes negative charge again. So this will be gone. Okay, and then this goes to there, goes to push. Okay, so this is a negative charge, and when it does, the R groups rearrange on the nitrogen. So that means that we R goes to from carbon to the here, so that bromine will leave because there is another donation of electron that pushes the leaving group, which is pretty good leaving group, right? And it goes back to the double bond again. Okay, and then whenever this nitrogen pick up the two hydrogens from the water, they make this is carbon later attacked by the another hydrogen anion. So this, when it's attached, is neutral, right? When they gets the hydrogen and another hydrogen, those hydrogen goes to here and to move. So once you get this one, it moves. Another one, it breaks it. So this one becomes carbon dioxide. And with this one, which is R and H2. Okay? Yeah. So that is why you have this one. Okay? You have you have a amine compound here. You just have to go through those three. I'm sorry, those three. That's become the rearrangement, not just removing the carbon group. You're rearranging this one to the here and gone. So this one. So there's no carbon here. Okay, it's gone as carbon dioxide. But yeah, but I just want you to remember what product will be there. Does it make sense? Okay. So let's try the practical problems. It will make more sense. So let's try. Can you guys try this one? Okay, about 30 seconds. Okay. So once again, this will be wrong. Okay, this will be wrong. Okay, this will be with what? Lithium aluminum hydroxide. Okay, so this will be this. Okay, makes sense, right? So you're not just removing the oxygen here, but also carbon. Just one. Makes sense, right? Okay. So I think this is a bit trickier than the others, but if you know the trick, it's just just do one more and I'll move on. Try the maybe. So in this case, you need to count the carbons. Okay. How many carbons should be there before you get to the minute? Okay, so yeah, so I'm gonna do the same trick over here. I'm gonna copy the rest, but here I'm gonna remove the whole thing, not just the oxygen here. So just do this one, right? So this will be this. Perfect. All right, looks good. So yeah, so that was it for chapter 24. This is the only thing I want to remember when you do the final exam for chapter 24. Because the subchapter is the most relevant to what we've been doing. So it won't be so hard to study the new chapter here. Okay, just need to do additional work. So from now, I want to hold the review. Okay, so let's try to do the review on chapter 20. So we have this one. Okay. Can you guys try this one real quick? This one. So this one real quick. Okay, but 10 seconds, we'll do this together. Okay, so here's the thing. Only thing you have to remember is this is the metal, right? This is the halogen here. So whenever you have a carbon dioxide, if you think about this carbon right here, this will be very electron poor. There's a two double bond on the both sides, not just even one. And those very electronegative elements are strongly bound to that central carbon. So this carbon is very, very electron poor. So this will be a very good target for this one, because this carbon, relatively speaking, electron richer, because this is a metal. They can easily compete with the metal for possession of the electron. So that goes to here. Okay. So then there'll be another one push on one of the oxygen here. So that makes this one, carboxylic. So then you just need to treat with some acidic condition will be what? Protonated. So it will be carboxylic. So this is okay. So let's do the other one. You guys try. Nitric compounds with the NaOH plus okay, but okay, about 10 seconds. Good. So this will be this one. So let me explain this one real quick, and then we can do actual practical problem here. So what happens? This one is the hydrox anion comes on this carbon, obviously electron very poor in the triple bond with the electronegative element nitrogen. And then when it do that, It has a more protonated with this one, and this goes to inositol tautomerism. It goes to in the amine compound. Okay, so inositol tautomerism, and then later water comes into this side, and hydrogen, one of the hydrogen on the water groups goes to so become better living groups. And then this hydrogen will be picked up by water, and this will be leave as ammonia because it's better living group now. So that part was replaced by hydrox group, which can hold carboxylic compound with ammonia. So this is what we did before. Yeah. So let's try the practical problem. Try to. This one. Okay, let's try this one. Okay, look at the cyanic group carefully and see how does. So you don't have to know the mechanism, but if you can get the trick, you'll be able to make the final product. Okay. There'll be quite a long process, but you don't have to know for the mechanism. If you can get some sense of getting some trick, you can do it. Okay, so this will be this one, right? So this carbon, okay, I'm gonna keep this carbon, and I'm gonna put the hydrogen compound, okay, and then ammonia. That's pretty much it. So it makes sense, right? You get the trick. So when you look at the cyanic group, focus on the carbon, where your carbon is, and try to make that the carbonyl groups and hydroxy group, that would be your carboxylic compound, and this leave as a ammonia. Okay. So this is what it is. We're gonna do one more. Can I move on? Move on? Oh, good. Okay, let's move on. Okay. All right. So then the next one. Oh, this is what we already did. Let's do real quick. This is also what we did this. Okay. Okay. Just real quick, you know what to do. This is what we did before. About 20 seconds. Okay, so yeah, here's the trick. As we know, this will be what I'm gonna do is they're gonna this one here. That's okay. So this is what you. That's it. So you just replace the triple bond and with the hydrogen from this agent, and you can have this the main mineral. That's pretty much it. Okay, let's try this one at this time. How about this one? We have same compound. Gonna trip with some greener. Oh, no, I'm sorry. This one. This is also very long mechanism, but if you can get the trick, it will be a lot easier. Okay, I'll tell you the trick real quick. Okay, so here's the thing. What you can do is you can try to remove this one and try to get the R part of your ring. So it would be R, MZX. Okay, you need to get R, which is a methyl group here, and just add it there, right there, on this card. So it will become ketone. As leaving this one as ammonia, right here. So that's it. Okay, so this is trick you can do whenever you have some cyanide group, natural parts of your compounds. Try to remove it and just get one R to there and put the carbonyl groups on the carbon. So it will be a ketone compound. So let's do just one more. Okay, let's do one more. Almost same, just different R group there. You need to get. Okay, so yeah. So it's pretty much the same, right? Pretty much the same. But I'm gonna add here ethyl group now, because this is the ethyl group here. I'm just gonna put this one. So this is all right. So I'll just stop here. So we ethyl group here. Add it on this carbon, and then you just have ammonia as a leaving groups, but this will be from here on that carbon, so it'll be ketone. Okay, that's a trick. Okay, so